My last video on 8.1 got cut off, so I don't exactly know how much of this problem you heard on that video, but here's my answer. If you want me to go through that, just come talk to me. We're going to go through this one now. Remember, our like terms are same letter raised to the same variable, so x squared plus x squared. Remember, if I don't have a coefficient on it, it's just 1. So 1x squared plus 1x squared is equal to 2x squared. When you think of it as an apple, I have 1 apple plus 1 apple. I have now 2 apples. Again here, x plus a negative, or x minus x. That goes away. It becomes 0, because 1 minus 1 is 0. Then 8 plus minus negative 1, or 8 minus 1, is positive 7. Okay, so here we have to just remember, like, this 1 is negative. This x is a negative. Okay, so we have a negative or a subtraction here. Remember, if it's subtraction, you need to distribute. So this negative becomes a positive. This negative positive becomes a negative. This negative becomes a positive. So we're going to actually change this to plus. And we can do that. So now we have squared, z squared, z squared. So I have 4z squared, 2z squared. Remember, if I'm adding or subtracting, I just add or subtract the coefficients. So now I have 6z squared. So I got rid of those. Now I don't have any other, just z's, so it's that negative 5z. And then this negative 3 plus 1, I'm just doing my work over here, becomes a negative 2. Okay, so combining like terms. And that is done. Negative again. So I'm going to distribute this negative within here. So this becomes negative x squared positive x positive 7. Now I can rewrite it like this if this makes it easier to look at. So 3x now, and 3x squared and a negative x. Well, that's a negative 1x. So really that becomes 2x squared. Okay, 6x and a positive x. So we have 7x. Then negative 4 and 7. Negative 4 plus 7 becomes a positive 3. Now, I could also think of this as negative 4 minus a negative 7. Minus a negative 7, which becomes plus, just like I did before. So this would be my answer. Okay, I have a negative again. Distribute this within here. So I have a positive 11t to the 4th, and, oh sorry, no, not a positive, negative. Let's just get that out of there, negative. And then this one becomes the positive 3t to the 2nd. So negative, I have t to the 4th, a negative 11t to the 4th. So again, 1 minus 11 is a negative 10t to the 4th. Okay, so I got rid of my fourths. Now my seconds, 3t plus 3t becomes a positive 6t to the 2nd. And then I'm going to do, so I got rid of those, and then I still have my minus 5t. And that just comes down there because I have no other one to combine it with. And our last example before we go on to 8.2. A nutritionist studies the U.S. consumption of carrots and celery of broccoli over a 6-year period. The nutritionist models the results in millions of pounds with the following polynomials. So carrots and celery would be this one, and broccoli is this one. In each polynomial, x equals 0 corresponds to the first year in the 6-year period. mathematical polynomial models the number of pounds in millions of carrots, celery, and broccoli consumed in the U.S. during the 6-year period. Okay, so here we're just asking to add these two together. They're not asking you to figure out anything else. They're just asking you to add them. It's just a word problem of adding polynomials. So I don't have any x to the third, so it's going to be that negative 12x to the third. Then I have x squared, so I have 106 plus 14, so that becomes 120 x squared. So I got that one, and that one. I have a negative 241x and a negative 14x, so combining those, I'm actually going to be adding them. 5. So I have a negative 255x, and then combining these two, so 1, 5, 4, 5, 11, 12, 10, 6. So then plus 6, 0, 2, 2. And that would be my answer, and I would want to write my label, carrots, celery, and broccoli. Okay.